Hello class, welcome to our lesson today. We're going to be looking at circles and circumference. I also have some information about the pi symbol and the number 3.14159, etc., etc. We're going to look at all those things today, so let's go ahead and get started. The first thing we're going to look at is just kind of a review of dealing with unit rates and some things with graphing. So for this question, it says the graph shows the cost of buying tickets. So it says what does the point 428 represent? So that's this point right here. And realize just use the labels on the x and y axis to help find that answer. So that's 4 tickets cost $28, which means the unit rate should be $7 a ticket. If you just take 28 divided by 4, each ticket costs $7, which corresponds to this spot right here, 1, 7. It's kind of hard to tell, okay, that spot, but you can use the other numbers to find that. Cost of 9 tickets then is 9 times 7, which would be $63. Letter D is probably the question that's most helpful, and it's just write an equation for the cost C of M movie tickets. So C, the cost, equals $7, or 7 times the number of movie tickets. And that would be an equation to represent those two pieces. And then you could plug that in any number of tickets or cost, and you can figure out the other variable very quickly. Okay, a circle. A circle by definition has a point in the middle, and then it's the number, or it's all the points that are an equidistant away from that point, which we call the radius. Okay, so from the center, the radius is the distance from the center to the edge, and you just go around. If you've ever used a compass to draw a circle, that's what a compass does. And then the diameter is the distance all the way across, okay, from one side to the other that goes through the center. And then don't forget that the radius is always half of the diameter, or 2 times the radius is equal to the diameter. That relationship is going to be important as you go through these sections. Next thing we need to look at is dealing with circumference. Circumference is the way we find what's basically the perimeter of a circle. It's called circumference. And that can be done in two ways. It's either circumference equals pi times diameter, or circumference equals 2 times pi times the radius. The reason these both work is the diameter is 2 times the radius. So that's really what we're doing. This pi thing is a little bit confusing. You've seen pi before. What you want to start doing is using the pi button on your calculators. I know that you can use 3.14. I would probably do a little bit more than that depending on the situation, but either way we should be able to get to at least close enough to the same answer as we're looking at circumference questions. So about this pi thing. Pi is basically a ratio that deals with circumference and diameter, and here's how it works. So here's circumference equals pi times diameter. If I divide both sides by the diameter, okay, just trying to get pi by itself, the circumference divided by diameter always equals pi. Okay, so this is more of a ratio. It's not saying that it's a unit. It's saying if I take the circumference divided by the diameter, every time I'm going to get this 3.14159 number, which is a very strange number, but it will be that every time. That's where that comes from. Okay, 3.14 is used as an estimate. Before calculators were used extensively, 22 over 7, if you divide that out in a calculator, gets close to what pi is. It's the closest quote-unquote easy fraction, okay, that we get to pi very quickly. Depending on the question, you could use one version over the other, but honestly, you should use the pi button on your calculator if you have a scientific calculator. If you have a scientific calculator, you'll be able to tell because it has lots of buttons. Okay, the basic 4-function calculator won't have all those buttons, but if you have a scientific calculator, you need to figure out where the pi button is on your calculator and be able to find out how to make that a decimal answer as well. So first thing we're going to look at is just find the circumference of an item. So this has the nickel has this $5 coin, has a 2 centimeter radius, which means the diameter is 4. Now, what you want to do, which your book does not talk about, let me repeat, your book does not talk about, is this answer in terms of pi. The expectation for our class is you're going to write things in terms of pi and then write it as a decimal or fraction, probably a decimal in most cases. So for this question, here's what we mean by that. So circumference is pi times diameter. So pi times 4 is 4 pi. 4 pi centimeters, because that's just a distance around the circle. 4 pi is the first answer we're looking for. So that's the answer in terms of pi. Just leaves the pi symbol in there. Everyone can find that regardless of what calculator you have. Everyone should have the same answer. It's when I plug in the multiplication of pi that we could get a slightly different answer. So I used the pi button and got this answer of 12.57. If you use 3.14, you might get 12.56. It's off by a little bit because you're not as accurate with your number for pi as I was with the pi symbol. You want to have both answers in terms of pi and as a decimal every time you're looking at these questions. The next one has a diameter of 14 feet, so the circumference is just pi times 14. That's the answer in terms of pi. Multiply that through, and I get just under 44, 43.98 feet for the distance around this pool. Again, I want to see both answers, and your book does not talk very much at all about this in terms of pi piece, and you need to do that to get full credit on many assignments for our class. You may also have a couple semicircle questions that deal with perimeter. So let's think about this half circle part. The perimeter, okay, notice I have 2 plus. You have to think about running a race. Think about this as a track or something. You got to do this half circle piece of the track and go back 2 feet to get back to where you started. So there's got to be a 2 no matter what. Then plus, I did the circumference of the circle, which is pi times diameter, but then I cut it in half because it's the radius versus, or I'm sorry, it's half the circle. Now what really happens is that becomes the radius, but when we start doing area questions, that idea doesn't work as well. So I'm going to keep showing that it's pi times the diameter and then divide by whatever I need. So if I have a fourth of a circle, I divide by 4. If I had an eighth of the circle, I divide by 8. Since I half the circle, I'm going to divide by 2. Notice, answer in terms of pi, 2 plus pi, and then I find the decimal point, decimal answer with rounded the nearest hundredth in this case to be 5.14. This question is exactly the same. The most common mistake is people don't put the plus 30 in. So this plus 30 is the diameter of this circle, and then plus pi times the diameter, divide by 2 because it's a half circle. So that'd be 30 plus 15 pi. When I find this final answer, remember, you got to follow the order of operations. You have to take 15 times pi first, and then plus the 30. Check that out on your calculator, whatever calculator you plan to use for any test situation. Make sure you're able to find that type of number of that 77.12. Okay, back to the pi thing a little bit, because honestly, talking about pi can be a very long process. So if you think back to like ancient Egyptians, they're the first group that really looked at this pi thing closer because they had chariot wheels and they wanted to reinforce the wheel itself. Okay, not just to be a wood wheel, but maybe some metal around the edge. So workers would have to figure out how much metal goes around this object. And what they found was if they took the diameter, the distance across the circle, they laid about 3 times that amount around the edge, that it got almost there, but they had to add a little bit extra. So they knew there was about a 3 relationship there. And that's where they first started developing this relationship between circumference and diameter. The Greek, specifically Archimedes, is credited with developing the number pi, not the symbol, the number pi. And that was just by looking at the perimeter of a polygon. For example, if you have a 3-sided object, a triangle, and then make it a square, a 4-sided object, and then a 5-sided object, a pentagon, and then a hexagon, and then, for example, an octagon, okay, an octagon, an 8-sided shape like a stop sign, you'll notice that it starts to look more and more circular. So if you keep adding more sides, it starts to look more like a circle from a distance. Think about a 100-sided object. If I told you to draw a 100-sided object, the lines would be so short it would look very circular. And so that's the idea of where the pi idea came from, because it was basically find the perimeter of an object, and they kept making those distances around the edge smaller by adding more sides, and it gets closer and closer to this pi number, 3.14159. The symbol pi was not developed until the 1700s or the 18th century. It was developed by the rock star of mathematics, Leonard Euler. Now, Euler is a famous mathematician. He was kind of like the best of the best in terms of what he developed during his time in his life. If you look at high-level mathematics later in your life, there's probably an Euler's formula or Euler's thing or Euler's this, Euler's that. He even has his own number. That's how much of a rock star he was in mathematics. So Euler made a publication in 1748 that basically said, okay, we all are talking about this circumference divided by diameter because we needed to find the area or distance around a circle. Okay, people were just using C or P or just any constant at the beginning of a pair to say, oh, by the way, that thing we're talking about, I'm going to use C. So Euler said, all right, I'm going to use the pi symbol. And the reason they picked the Greek letters like pi is because the Greek language at that point was considered to be a dead language. No one was using those letters all the time. Okay, some people were in different areas, but that symbol could be used, and it probably related back to our friend Archimedes with the Greek alphabet as well. But you'll notice in mathematics that the Greek alphabet, because it's quote unquote a more dead language, so to say, is used to represent things in mathematics. So Euler said, well, let's use this pi thing. And everyone thought, well, he's the rock star, so we might as well fall in line and use it as well. So it kind of just is somewhat happenstance at that point, but someone had to unify everyone to say, this is what we're using for pi. And that's what they decided on. And that represents that distance around the circle divided by diameter, or 3.14, etc. How many digits long is pi? We don't know. It goes on forever, it never repeats, and it doesn't end. That's an example of an irrational number. Pi is the most famous irrational number in the world, and people have worked a very long time to try to figure out if it was rational, which meant it either ends, terminates, or the decimal would repeat itself. But up until this current time, it still has not been found that it does either of those. Computing pi has become much easier because of computers, and there's an algorithm to find the next digit of pi, etc., etc. When I found some information most recently, because computers and universities can just constantly be running this now, computers have basically counted out to 22 trillion digits, and it doesn't repeat and it doesn't end. For example, this version in 2017 by Peter Treb took 105 days and took 9 terabytes of disk space to compute it. If you understand anything about computers, that's some serious work there. It would be several million books containing thousands of pages each. Okay, think about writing all that out by hand. Okay, it would take you forever to find that. And even with that, it hasn't repeated and hasn't ended. If you figured out that pi ended, terminated, or repeated, first off, it would be top story on the news. Second off, every other mathematician would probably think you're lying, because people have been working on this literally their whole lives to figure it out. And they still haven't figured out if it ends or repeats, which means it must be this irrational number. If you want to know anything about memorizing pi, if you thought you were cool because you thought 3.14159 and you were really cool because you memorized that many digits of pi, the world record is 76,890 digits in 2005. I'm sure there were some stipulations about using the restroom or getting some food and drink of water and things like that. But people would be looking at the digits. There'd be a panel probably listening to this gentleman talk about these digits and go through the list. So the Chao Lu, this gentleman right here, must have a photographic memory. If you hear people about memorizing numbers in a phone book or from something like that, the story has it that he got to this number and he knew more than that, but he messed up a spot and would have been able to keep going even further, maybe to 80,000. That seems just like a lot of work to me, but more power to the guy. He's in the Guinness Book of World Records, and here we are talking about him for memorizing digits of pi. Okay, we care if pi repeats because if it could repeat, it would be a rational number. If it ended, it's a rational number. Just for a reference, NASA uses 15 digits of pi for their calculations. So if NASA only uses 15 digits and they can get to the moon and back or send a rover to Mars or whatever they're doing, it must be okay for what we're doing in a math class. Okay, here's your homework, section 8.1. There's a lot of different questions here that you want to look at. Remember to write your answers in terms of pi, and then as a final answer, the expectation is you're going to have both on all those questions, anytime you're dealing with circumference, and then when we deal with area of circles. Have a good day, everyone.